The first thing we're going to discuss is the order of operations. Excel does more complex formulas, that is, formulas with multiple operations in them, say multiplication and division and addition and paste functions and so on and so forth, in a specific order called the order of operations. This order of operations comes from algebra. You remember high school algebra, your favorite class? We're going to show you the rules by which Excel does those multiple calculations. I've opened a new workbook in Excel, and we'll start by creating a very simple formula just using numbers to show you how the order of operations works. The formula will be equals 4 plus 5 times 6 plus 7. This formula involves mixed operations, both addition and multiplication. In my classes, I ask my students to tell me what the result is of this equation. I get several different answers commonly. The difference comes because different people do the equation in a different order. Some add the 4 and the 5, multiply by the 6, and then add the 7. Others multiply the 5 and the 6, and then add the 4 and the 7. And occasionally I have people that add the 4 and the 5 and the 6 and the 7 and multiply the result together. There is, however, a set of rules governing this. Let's go ahead and enter this equation, 41. I'm going to move back up so we can see the equation again up in the entry line. To get 41, the 5 and the 6 are multiplied first to get 30, and then the 4 and the 7 added to get 41. This is the correct answer because this follows the rules of the order of operations. Let's take this equation and copy it down one cell into cell A2 by using the autofill handle. And now I'm going to click down on this formula, and I'm going to put a parenthesis in front of the 4 and a parenthesis following the 5 before the multiply sign, a closed parenthesis. Now the equation says equals 4 plus 5 times 6 plus 7. When I enter this, the result is 61. In this case, because of the parentheses, the 4 and the 5 are added together first, then multiplied by 6, and then the 7 added. The result is 61. Finally, I'm going to copy this equation one more time down into cell A3. Click down here, and I'm going to put a set of parentheses around the 6 and the 7. What this does is force the equation to do both additions first and then multiply the two results. So 4 plus 5 is 9, 6 plus 7 is 13, and 9 times 13 is 117. The actual order of operations is paste functions are done first. We're going to be working with these a lot in this tape. Next, anything in parentheses is done second. After that, any exponentiation that needs to be done, raising numbers to powers, taking logs, that sort of thing, is done. Then it does multiplication and divisions. These are done at the same level because the order in which you multiply and divide a string of numbers doesn't matter. Finally, the last operation is additions and subtractions. Again, the order in which you add or subtract a string of numbers doesn't matter, so they're at the same level. In our previous equations here, the first equation, it did the multiplication first, and then it added. In the second one, it did what was inside the parentheses first, which was an addition in this case, and then it multiplied, and then it added. So it was following the order of operations. And again, in this equation, it did what was inside both sets of parentheses first, that is, both additions, and then it did the multiplication last. Fortunately for all of us, this is not an algebra class. However, you need to be aware of the rules of the order of operation as you create more complex formulas. Always test your formulas very carefully before you assume they're correct. Next, we're going to explore a few of the basic paste functions. Actually, if you did the beginning tape, you've already used one, the sum function. It has a tool on the toolbar specifically to make it easier to use since it's used so frequently. We'll talk about the sum function, but we'll also talk about two other functions, the average and count function, and how you access these since they don't have tools on the toolbar. Let's select cell A5, just by clicking on it, of course, and then go up and click on the summation tool, the auto sum tool. It's a smart auto sum. It actually does a search in cells above it and to the left of it, looking for cells with numbers in them. In this case, when it searched upward, it found this column of numbers, so it assumed that that's what we wanted the total of. It's correct. Notice the format of the sum command. This is a paste function, and it is the same format for all paste functions. It inserted the equal sign for us since it was the beginning of an equation. It doesn't always do that. If this is later in an equation, it'll just put it in the equation. Then comes the function name in capital letters, in this case, sum. Next we see a set of parentheses. All paste functions have a set of parentheses following the function name. Inside the parentheses go what are called arguments. In this case, the arguments are simply a range of cells, cell A1 to A4. Excel shows us a range of cells by giving us two cell addresses separated by a colon. Other paste arguments that we're going to use further on in this tape will have much more complex arguments than simply a cell range. For now, we'll just click on the check mark and enter that paste function into that cell, and down in the cell, of course, we see the sum of those three numbers. We could also take an average of these numbers if we wanted to, using the average function. There's no tool up here on the toolbar for that. Let's go down to cell A6, select cell A6, and this time, if we know the average function, and it just is the word average, we can just type it in. We can put in our equal sign to tell Excel this is a formula, and then type in average. Now I always type it in lowercase. If you type it in lowercase, and then when you enter the completed formula, Excel will put it in uppercase to tell me that it recognized this function. This is a very simple but very handy debugging tool. Now I have to type in the opening parenthesis, and now I have to tell it what cells I want to take an average of. We could type in the cell addresses, or we could just take the cursor and use the pointing method that we learned in the beginning tape and click and drag from cell A1 down to cell A3. Let go of the mouse and then type in our closing parenthesis. Once we type that in, we can just enter it, and now we see that the average of those three numbers, 41, 61, and 117, is 73. Notice that when we entered it, Excel made average into capital letters, telling us that it recognized this function. There's a third way to access paste functions. Only the sum function has a tool on the toolbar, although with the customization features of the toolbar, we could create tools for commonly used paste functions so we could reach them directly on the toolbar. Other functions, if we know the names, we can just type them in. If we're not sure of the name or of the arguments, we use the paste functions from the list under the insert function in the menu. Let's do that now with the count function. Let's select cell A7 and then come up and do an insert function command. This brings up two boxes in a dialog box. The box to the left is the function category. The first function category is most recently used, and over here in the function name box we see the functions that have most recently been used. This gives us easy access to functions that we use frequently. If we click on all, we'll see a complete list of all the paste functions that Excel has. It's quite a long list. Then we see breakdown by different types of paste functions. Financial functions, which we'll use in a little while to create an amortization table, date and time functions, math and trig, statistical, and so on and so forth. What we want, the count function, is a statistical function. So we click on the statistical function category, and then we look over here in the list, and down here the last one showing is count. If we click on count, and then we click on the next button below, it now asks us what values we wish to count. We can also insert a paste function using this button. This is for what's called nesting paste functions, that is, putting paste functions inside paste functions. If you're listening to this tape, you probably aren't ready for this yet, but we certainly can do it, and it can get very involved and complex. All we need here, though, is some cell addresses. So if we come up here to cell A1 and click and drag down to cell A3, because those are the three values we want to count, and then we just click on Finish. Now you see that it counted out of those cells how many cells had numeric values in them. 3 of them. And it also entered the count function into that line with the arguments that we selected. We've now learned how to use basic paste functions such as sum, average, and count, and the 3 ways you can access paste functions: from the toolbar, from just knowing the paste function and typing the name in, or from the paste function dialog box. Usually when you first use paste functions, you'll probably have to go to the manual. Yes, I'm sorry, you're going to have to go to the manual occasionally and look up the appropriate paste function and what its arguments are and how they're defined. As you're going to see in some of the more advanced paste function, all of them are not as straightforward as the sum, average, and count functions. Now let's look at some options in terms of setting up the software and how the spreadsheets and workbooks are presented to us when we first load them. This is done under the Tools Options command. Let's look at it now. Let's do a Tools Options command. This brings up another of the new formatted dialog boxes in Excel 5.0. Notice the tabs which cover all aspects of Excel 5.0 and how it presents information to us initially. The first tab is the View tab. This has information covering the view, how numbers are displayed, whether formulas are displayed or not, and so on and so forth. At this point, we're not interested in changing any of these. The ones we want to look at are in the General tab. There are tabs for how it does calculations, how editing's done, and so on and so forth. Let's click on General. This now brings up a dialog box. The options we want to talk about and change are in here. The reference style we'll leave at A1. This other reference style, R1C1, applies to macros. We'll talk about that in the advanced tape. Over here under Menus, we have a couple of options here. One is the recently used file list. If you've gone into Excel more than a couple of times, you'll notice that when you click on the file choice in the menu, down at the bottom of the menu, you'll see a list of recently used files. I'm going to close out of here just by canceling and show you that. Click on File, and now you'll see down at the bottom, I have Budget, which is a spreadsheet we created in the beginning tape, and Book 2, another one that I was working with. I'm not going to select any of these, but those are recently used files. I'm going to come back and do Tools Options again. You can turn off that recently used file list, but normally it'll store the 4 most recently used files. If you use the same files over and over again, that's real handy to have it there because you don't have to go into File, Open, and scroll down through the list and find your files. They'll be listed down there. So I like to leave that turned on. You can also change back to Microsoft Excel 4.0 menus if you prefer those over the new Excel 5.0 menus. However, my experience is once you get used to these Excel 5.0 menus, they are extremely powerful, far more powerful than the 4.0 menus were. We can also do a lot of other things in here. One of them is we can reset the tip wizard. The tip wizard keeps a list of all the tips in this session of Excel, and we can tell it to reset it back to the very beginning of when we first loaded Excel, so it starts over again from the beginning. The main one I wanted to show you in here is the number of sheets in a new workbook. The default is 16 sheets. I don't know why Microsoft chose that. I don't think many of us normally want 16 sheets in a workbook. That's an awful lot of sheets. I generally change this for my purpose down to a much lower number. For class, let's set it to 2. Later you can set it to whatever number best suits your needs. We can also in here change the standard font that Excel uses in all workbooks, in all worksheets. The default is Arial 10 point. However, if we change this, to actually see the change take place, we have to close Excel and then reopen it. So I'm going to leave that Arial 10. But if you prefer a different font, you might want to change this and then close Excel and reopen. Below here is where the default file location goes. Normally, we would store our data files in a data folder somewhere. You could put the path and name of that data folder under default file location. You can also have an alternate startup file location. And finally, of course, the username of the software, which is the name you put in when you first installed Excel 5.0. The only thing we really changed here was the number of sheets in a new workbook, and I changed that to 2. Let's click OK then, and close out of the Tools option box. Now I'm going to close this workbook, this 16-sheet workbook. Double-click up here on the control icon. Tell it, no, I don't want to save any of this. And now I have Excel with no worksheets loaded. Now if I click on the new workbook tool, the first tool over here at the left end of the toolbar, it creates a new workbook, but now the new workbook only has 2 sheets instead of 16. It's so easy to add sheets that I much prefer having a few too few than way too many. As you saw in the menus, there are a lot of options in there under Tools Options. You probably want to peruse these at your leisure so you know what's back here. As your skills with Excel increase, you may want to change more and more of these. Be careful, however, not to change ones that you don't understand what they do unless you're really watching carefully. You can get in a lot of trouble that way. I know, I'm talking with the voice of experience. Now we're going to talk about one of my favorite improvements in Excel 5.0, 3D spreadsheets. This is vastly improved over Excel 4.0, much easier to use and far more powerful. We can create workbooks, that is groupings of spreadsheets, and enter data across multiple spreadsheets, some data across those spreadsheets. We can add spreadsheets to the group or delete ones out, and it's all very quickly and very easily done. Let's take a look at it. We're going to create a couple of spreadsheets for an imaginary company with sales offices in 2 separate cities. We're going to have the salespeople in each spreadsheet for each city, so the spreadsheets will have some things in common, such as formulas and some column headers, and some things that are quite different, such as the salespeople and the dollar amounts they sold. First, let's name the 2 sheets. The default names for the various tabs in the sheet are Sheet 1, Sheet 2, etc., as we've seen before. Now let's rename the sheets into something more meaningful. To name a sheet, all we have to do is double-click on the Sheet tab. I'm going to double-click on the Sheet 1 tab, and that brings up the Rename Sheet dialog box. My 2 offices in 2 cities are going to be the Denver and Omaha office, so I'm going to type in here Denver and press the return key, and now I've named this spreadsheet Denver. On Sheet 2, I'm just going to double-click there and name this one Omaha, and enter that. Now I have my 2 sheets for the 2 different cities. Some information will be common to both sheets, such as the column headings and the formulas that are going to calculate information based on their sales. Let's go in and start by putting in some column headers that are common to both sheets. To do this, we want to select both sheets, Denver and Omaha. All we have to do is click on Denver and then shift-click on Omaha. Now you'll notice that both sheet names are selected at the bottom here, which means anything I enter into a cell here in the Denver spreadsheet will automatically be entered into the Omaha sheet. Let's go down to cell B4 and let's type in here January. And let's tab over, and in cell C4 let's put in February. Then tab over another cell and let's put in January %. We want to know what percent of the total sales for the month each salesperson was responsible for. Let's go take a look at our Omaha spreadsheet now. Just click down there on the tab to switch to the Omaha sheet, and you'll see that all these column headings we put in here are now on the Omaha sheet as well as the Denver sheet. Let's switch back to Denver. The salespeople's names now we'll put down in column A. These will be unique to Denver, so we'll just put them in the Denver spreadsheet. We'll put in Joel in cell A5, Brian in cell A6, Cheryl in cell A7, and finally Karen in cell A8. 4 salespeople will be enough for our purposes. Let's highlight the range where we want the data to go, and now if we enter the numbers into these cells and press the enter key, it'll just enter the data down the first column, then go to the top of the second column and enter the data down that column. If you use the numeric keypad and the enter key, this makes it much easier to enter the numbers. We now have our sales figures for the 4 salespeople for the 2-month period. Next, let's go over to the Omaha sheet and let's put in our 4 salespeople and their sales figures. We can do all of these at once. We now have the data that is individual to each spreadsheet entered. Now we want to put the formulas in to calculate the percentages and the total sales for each month. Let's put the total sales in because we're going to need these numbers to calculate the percentages anyway. We're going to leave some blank rows between the salespeople and the totals so that if new salespeople come along, we can add them to the list. We'll go down to cell A12 to put these in, and we will group the 2 spreadsheets again by holding down the Shift key with Denver selected and clicking on Omaha. Now we can put into cell A12 totals, now we're going to put our formulas in for the sums down here in these 2 cells so we can highlight both cells and click on the summation tool. It automatically found these numbers and took the sums. You'll notice the formula also included the blank cells above the summation and underneath the existing salespeople's figures. That way, if we add new salespeople's, their sales figures will automatically be added into the totals. Let's come over here to the January percent column. We want to know what percentage of the total January sales Joel was responsible for. In Omaha, we want to know a similar kind of thing, so we'll do it for both spreadsheets again. We'll start with our equals sign, and then we'll just come over here and click on Joel's January sales, $15,200, cell B5. Now, we want to keep in mind as we enter cell addresses to think about the appropriate kind of cell address in each formula. Usually what determines what kind of cell address we want to use is whether we're going to copy this formula, and if so, where. If we aren't copying it anywhere, it really doesn't much matter what kind of cell address we use. However, in this case, we're going to want to copy these formulas down this column for the other salespeople, and then we're going to also want to copy these formulas over into February. So we have to think about this address, B5. When I copy downward, what's going to happen to this cell address? Well, if I use a relative cell address, the default kind, it'll change to B6, to B7, and to B8 as I go downward. Is that what I want it to do? Well, it is. I want January's percentage of sales for Joel to go to Joel's January sales figure. When I come down one cell, I want it to go over and get Brian's number, and so on. So the relative address here works just fine. Let's put my slash in now for the division. And now we want to divide by the total, cell B12. I click down there on cell B12. Now, do I want this cell address to change when I copy this formula down and to the side? Well, as I go downward, if I use the relative address, this will become cell B13, B14, and B15. But I don't want that. I want it to stay on cell B12. That would imply maybe an absolute address. However, then I have to think about what happens when I copy these formulas over into the February column. When I copy this formula over into the next column, using an absolute address on the bottom cell and a relative address on the top cell address, it would be equals C5 divided by B12. Well, the C5 would work fine. That's Joel's February sales, and that's what I want in the February percentage column. However, the absolute address, B12, would refer to the total January sales, not to the total February sales, which is what I want. That means that I need a mixed cell address here instead of an absolute cell address. With the mixed cell addresses, part of the address stays fixed while the other part of the address changes. The part that I want to stay fixed is the row. I always want to go to row 12 looking for the total sales, but I want the column to change when I copy the formula from the January column into the February column to column C for the total sales. So I'm going to press the F4 key once, and that changes the address to $B, $12, the absolute address. A second time now changes it to B, $12, the mixed address that means that the row is going to stay constant, but the column changes. That's exactly what I want, so I'm going to click on the check mark up here. This gives me my January percent, that is Joel's January sales divided by total January sales, and that's correct. If we want to use this formula for the rest of the salespeople, we're going to grab the autofill handle and click and drag downward to Karen's row. We now have the sales percentage for each person in the month of January, and we grab the autofill handle and drag over into February's column. While we have all these cells selected, let's just go up here to the formatting toolbar and click on the percentage tool. We now see them as percentages of total sales. We now have the basics of the spreadsheet for the two cities. The next thing we'd like to do is create a summary spreadsheet for the home office, reflecting the total sales across all offices for all salespeople. Let's add a new spreadsheet to this group of spreadsheets and make it a summary sheet. Let's select the Denver spreadsheet and then come up and do an Insert Worksheet command. This puts a new worksheet in, and if we double click on that sheet tab, we can name this Summary Sheet. We want to summarize the total sales for both January and February for both Denver and Omaha offices. Let's go back to the summary sheet and in cell A12 put in sales totals. Tab over to cell B12 and click on the summation tool. There's nothing to sum, so it merely inserts the sum paste function and the parentheses, and it's waiting for us to tell it what the arguments are. Let's go over to the Denver spreadsheet and then shift-click on Omaha to select both of these sheets. Now let's click on cell B12. Now we can click on the Enter button, and that now enters the summation formula across two spreadsheets. Notice this formula is equals sum parenthesis Denver colon Omaha exclamation point B12. Denver colon Omaha is a range name using spreadsheet names instead of cell addresses. The exclamation point tells us that these preceding names were spreadsheet names rather than range names. Finally, the cell address B12. So it's summing all spreadsheets from Denver to Omaha on cells B12. We can now autofill over into the next column to get the sums for February. We might want to label these two columns Jan, enter that, and then grab the autofill handle and label that one February. Let's also adjust this column width that says sales totals. Come up here to the divider and double click. We now have the beginnings of a summary spreadsheet covering all offices, due in part at least to the excellent record keeping we've kept in Excel 5.0 of our business doings. We're going to open a new office in Timbuktu, Wisconsin. This will necessitate creating another spreadsheet with similar information as we have for the other two cities. Let's select the Omaha spreadsheet. When we insert new spreadsheets, they'll go before the selected spreadsheet. If we select Omaha and do an insert worksheet command, it inserts a new blank worksheet between Denver and Omaha. If we double click on the Name tab, we can name this one for our Timbuktu office. Since this spreadsheet is between the Denver and Omaha spreadsheets, and the summary formulas show a range of Denver to Omaha, any numbers that we put into the Timbuktu spreadsheet in cells B12 or B13 will automatically be summed in our sales totals. Let's go to Denver and let's copy all the information that we can over to the Timbuktu spreadsheet. We can take the column names certainly and just copy those over. This time we'll copy using the copy tool. Then go over to the Timbuktu spreadsheet, select cell B4, and we can click on Paste. Let's go back to Denver now and take the formulas that calculate the percentages. This time, let's use the sub-menu by clicking on the right mouse button and do a copy there. Then let's go to Timbuktu, select the first cell, click on the right mouse button, and do a paste. We get division by zeros right now because there are no totals down here. But when we fill in the numbers and the totals, these problems will go away. Let's now go back to Denver one last time and take our totals. Click on the right mouse button and select Copy. Then let's go to the Timbuktu spreadsheet, click on cell A12, click on the mouse button, and click Paste. Of course, the totals are zero right now. There's no numbers. Now we're ready to start putting in our Timbuktu salespeople. Let's put in their sales figures. You'll notice as we put the numbers in, the division by zero errors went away and our totals appeared down below. We now have three cities, Denver, Timbuktu, and Omaha, with their totals. And if we look now on the summary sheet, since we inserted the Timbuktu sheet between the Denver and Omaha sheets, where the sums were taken, Denver to Omaha, we now have totals for all three cities displayed in the summary spreadsheet totals. Working with 3D spreadsheets in Excel 5.0, we can enter text or formulas or numbers across several spreadsheets that are not adjacent. In this case, if we wanted to enter a new salesperson who did some sales work in both the Denver and Omaha offices but not in the Timbuktu office, those two spreadsheets are not adjacent. If we move them around until they are adjacent, the totals for the Timbuktu office will no longer be included in the totals in the summary sheet. So rather than do that, we'll select the Denver and Omaha spreadsheets and add a new salesperson, Tim, who does some work in both offices, and then we'll go ahead and see that the numbers appear in the summary sheet in the appropriate manner. I already have Omaha selected, so all I have to do now is hold down the Control key and click on Denver. That means now anything I put into the Omaha spreadsheet will automatically go into the Denver spreadsheet as well. I'm going to come up here to cell A9 and put in Tim, my new salesperson, and enter it. Now if I come over and click on the Denver sheet, you'll notice that Tim was added here as well as to the Omaha sheet. But you'll notice that the Timbuktu sheet, which was not selected at the time, does not have Tim. We can select different spreadsheets in a group by control clicking on the tabs of each one, and then anything we do in one of them will automatically occur in the others, but not in the ones that aren't selected. That includes formatting as well as cell entries, deleting, and that sort of thing. Let's put in Tim's sales figures for the Denver office in January and February. Then let's go to the Omaha office and put in Tim's sales for both months there. The numbers are reflected in the totals for the two offices and therefore reflected over in the summary sheet as well. We've now created three-dimensional spreadsheets, multiple page spreadsheets. We've entered text, formulas, and numbers across those multiple sheets. We've also summarized across multiple sheets using a sum function. We've added new sheets, deleted sheets, and moved the sheets around within the multiple spreadsheet layout. Next, we're going to create a sales commission table. We've decided to pay our salespeople a bonus or commission based on how much they sell above $15,000. We're going to give them a 10% commission on everything they sell over $15,000. We're going to have to create a table that first determines if they sold over $15,000 and if they did, how much bonus to pay them. If they don't earn a bonus, it'll show no bonus in the table. We're going to use a logical function called the if function to do this. Since these formulas are going to apply in all of the cities, I'm going to click on Denver and then I'm going to shift click on Omaha. Now any changes or additions I make to the Denver spreadsheet will automatically occur in the Timbuktu and Omaha spreadsheets as well. Let's come up here to cell F4 and put in here January, Jan, bonus. I'll tab over and put in February bonus in cell G4. Let's go now to cell F5 and calculate Joel's January bonus. We're going to paste in an if function here. We're going to use the function wizard tool up on the standard toolbar to do that. I'm going to click on that tool and it now gives me a list of functions, the same list we got when we did an insert function command. The function we want is a logical function, so we click on logical, and the particular logical function we want is the if function. Now let's click on the next button. There are three arguments to the if function. The first argument is a logical test. We have to test to see if something is true or false. Next, we have to decide what to do if it's true, and finally, what to do if it's false. A logical test will simply be to check and see if Joel's January sales, cell B5, let's click on B5, is greater than, and we'll just type in a shift and a greater than symbol. That's the shifted period. And the breakpoint we're going to use is 15,000. So this is going to test to see if Joel's January sales, cell B5, is greater than 15,000. We tab down to the value if true field. We want to enter the formula that will apply if indeed Joel did sell more than 15,000. We've already said that we want to pay a 10% bonus for everything they sell above the breakpoint, the 15,000. We'll put a formula in here which will be an opening parenthesis, and then we'll take B5 again, Joel's January sales, and subtract 15,000 from it, close the parentheses, and that'll give us the amount over 15,000 that Joel sold. And now all we have to do is multiply that by 0.1, which is the same as multiplying by 10%. Finally, we tab down to the value if false argument, the third and final argument in the if statement. In this case, we want to put in text. Text always goes in between quotes, so we're going to put in quote, no bonus, close quote. Notice in the function wizard box, it's telling us here in this box whether the current cell, that is Joel's January sales, B5, is greater than 15,000 or not. In this case, it's true. After it tells us it's true up here, it comes down and evaluates the value if true. The value if true is Joel's January sales, B5, 15,200 minus 15,000, that'd be 200, times 0.1. Joel's bonus is going to be 20. The text no bonus will always just show up as no bonus. In this case, since the statement is true, the value we're going to see in the cell will be the 20. Let's click on Finish. Now you see Joel's January bonus is $20. Notice the formula as it appears up here on the entry line. We have the if statement, followed by the parentheses for the argument, B5 greater than 15,000, comma always separates arguments. Then we have the next parenthesis to separate B5 minus 15,000 and make sure we do that subtraction first before we multiply by 0.1. Finally, another comma for the value if false, which is text no bonus. We'll see this text appear when we copy this formula down for people who sold less than 15,000, such as Brian did in January. Let's look at our cell addresses. Do we want relative, absolute, or mixed cell addresses for B5 and B5 here? When we decide what kind of cell address, we have to think about where we're going to copy the formula and what's going to happen to the cell address when we do that. We're going to copy this formula across and then down. By the way, it doesn't matter if we copy down and then across or across and then down. That'll give us the same thing. So let's talk about, in this case, copying across and then down. If I copy this formula from cell F5 over into cell G5, this cell address, being a relative cell address, will change. Think about that. What cell address is it going to be when I copy it into cell G5? It's going to be C5. It's going to move over one cell from B to C. Is that what I want in cell G5? Do I want to compare C5 to 15,000? Well, yes, I do. The February bonus should be based on Joel's February sales, so that address would be correct. So the relative address will work just fine for copying this formula over into the February column. Now, what's going to happen when I copy both formulas down for the rest of the salespeople? Well, as you can see, if I fill these addresses downward, the B5 in that case is going to change to B6 when I get down to the row for Brian. That's exactly what I want. If you follow this logic through, you'll see that the relative address works just fine in both cases. It's exactly what I want. So I'm going to autofill from January over into February. Now we want to fill down. I'm not going to fill down all the way to Tim. It would be pretty unfair to Tim, who did sales in 2 cities, to base his bonus on sales in each city separately against a $15,000 breakpoint. His sales should be based on his total sales in both cities against the $15,000. So I'm going to autofill down just as far as Karen, row 8. Now you can see the bonuses that each salesperson gets in each month. You also notice that Brian failed to make the $15,000 breakpoint in January, so he receives no bonus in January. Now let's fill in Tim's percentages. All we have to do is highlight the percentages in the formulas above and autofill down one cell. Now let's look at Tim's bonus. Now we want to put Tim's bonus in, but we want to consider his sales in both the Denver and Omaha offices when we calculate his bonus. Now we're only going to pay him a bonus in one office, so we have to choose whether we're going to pay him in Denver or Omaha. We'll just select Denver. To deselect the other two, we can just shift-click on Denver. The next thing we want to do is copy the bonus formulas down into Tim's January and February bonus cells. So let's highlight the 2 cells above, grab the autofill handle, and drag down one cell. Now obviously at this point, Tim's getting no bonus in either because his sales are much too small. But now we're going to modify this formula by coming up here and clicking behind B9. And now we're just going to hit the Add button and go to Omaha and click on Tim's sales in Omaha. So basically we're adding B9 in the Denver spreadsheet plus the Omaha B9, and we'll do the same thing over here on this B9. Add Tim's January sales in Omaha as well to both spreadsheets, and now simply press Enter. This moves us back. You now see Tim's going to get a $70 bonus. Let's check and make sure our calculation is correct. Tim's January sales in Denver were $7,200, and his January sales in Omaha were $8,500. That would total up to $15,700. That would mean there would be a $70 bonus, and that number's correct. We can just click on this cell now and autofill over here into the February bonus as well. Now Tim is being paid a bonus based on his sales across both states, Denver and Omaha. Now we're going to apply a very powerful feature of Excel 5.0 to our commission table. While named ranges existed in previous versions of Excel, the enhancements make them much easier to use. Let's see them. When we built this spreadsheet, the breakpoint, the $15,000, the point which determined whether a salesperson got a bonus or didn't get a bonus, was embedded in our formulas. If we want to play what-if games with these spreadsheets and change that breakpoint to see how much bonus people would get if, say, the breakpoint were $14,000 or $15,200 or something like that, we'd have to come in and edit one of the formulas and then autofill across the rest of them. Let's change it so that this breakpoint refers to what we call an external cell reference. That is, we'll put the breakpoint number, the 15,000, in another cell somewhere in the spreadsheet, and then put the cell address in place of where we have the 15,000. Let's go up here, say, to cell B2, We're going to enter the breakpoint in cell B2. However, we want to put the breakpoint on all three sheets so everybody working on it can see what the breakpoint is, even if they're not looking at all three. So let's come down here. We have Denver selected. Let's shift click on Omaha. That selects all three sheets. Now in cell B2, we'll type in 15,000 and enter it. That's going to be our breakpoint. Now come over here to the first formula, Joel's January bonus, in cell F5. Remember, we have all three spreadsheets selected, so any changes we make in this formula will automatically occur across all three spreadsheets. When you do this in real life, you'd probably want to decide if each office was going to have a separate breakpoint or if it was going to have its own breakpoint. That would determine whether the breakpoint was controlled from one spreadsheet or from several. In this case, we'll put a breakpoint in all three and allow each office to change, if they want, the breakpoint. Let's go up here now where we have the 15,000 and double click. Put your cursor on the 15,000 and double click. That selects that number automatically for us. And now I'm just going to click on cell B2. Now as I enter this cell address, I want to think about what kind of cell address I want here. What's going to happen to this cell address, this relative cell address, when I copy this formula over and down? Well, when I copy the formula over into column G, this cell is going to change to cell C2. There's nothing in C2. That would be very generous bonuses. If they sold more than 0, they would get 10% of everything they sold above 0. I'm not that rich, I can't afford it. So we want to make sure that this cell, cell B2, stays the same when I copy the formula. I'm going to press the F4 key, and that's going to change it to an absolute cell address. I always want the bonus to be based on this breakpoint in cell B2, so the absolute address is correct. I want to go through the same process here with the 15,000. I'm going to double click on this occurrence of the 15,000 and again click on cell B2 and press the F4 key. So now I've changed both occurrences of the 15,000 to refer to this cell B2. I'm going to enter that formula now. Doesn't change anything. It's the same breakpoint, so it'll be the same bonus. But now I'm going to autofill over into February. When we autofill down, we want to go only as far as Karen's bonuses. Remember, Tim's bonus is based on 2 different states, so we're going to have to modify those formulas separately. I'm going to grab the autofill handle and drag down to row 8, the row with Karen's figures in it. Now I'm going to come down to cell F9 where Tim's bonus is, and I'm going to separately change these because I don't want to erase the B9 plus Omaha B9 portion of this formula. I'm going to double click on the 15,000 and click on cell B2 and make that an absolute address. Double click on this 15,000, click on cell B2 and make that an absolute cell address. And I'm going to enter that formula. Select that cell and autofill over into Tim's February bonus, cell G9. Now, all the cells on all 3 spreadsheets refer to the appropriate cell B2 on that sheet. If I change the breakpoint, since I have all 3 sheets linked at this point in time, if I change the breakpoint, it will change for all offices. I'm going to change it to 14,000 and enter it. Obviously, there are more bonuses being paid, much higher bonuses, and if I look across the other sheets, the breakpoint there is changed to 14,000 as well, so there's more bonuses being paid there as well. Now we can play what-if games with our breakpoint and see what the effect would be on our bonuses throughout the company. There's an even easier and better way to do this same thing. Let's go up here to cell A2 and type in the word breakpoint. Enter that. These formulas are still kind of confusing to read. If you look at the formula, it says equals if B5. Well, what's B5? I have to come over here on the spreadsheet and look. That's Joel's January sales. As I'm creating the spreadsheet, this may not be too difficult, but if I come back weeks or even months later and I want to figure out the spreadsheet or change it, or someone else entirely wants to come in, it's pretty difficult to figure out what all these cell addresses mean. Range names can be substituted for cell addresses anywhere where the software looks for a cell address. So for example, in this formula, this could be if Joel January would be the range name for that cell there, is greater than breakpoint, comma, then Joel January minus breakpoint times 0.1. We would replace the cell addresses with text. Then it's very easy to come in at any point and look at the formulas and understand pretty quickly what they mean. Let's do it in stages. Let's start with this first formula again, Joel's January bonus, cell F5. And let's change the references for a cell to cell B2 from a cell name to a range name. The first thing we need to do is create the range name. Let's click on cell B2. Come up here, and in the cell address field in the entry line, we're going to change this. If we click on the down arrow, it highlights the address, and now we can type in breakpoint. Let's enter that. That means now that cell B2 has a name, and that name is breakpoint. We can use this name in place of the cell address B2 in any menu, in any formula, or anywhere where Excel is looking for a cell address. Let's come down now to our first formula, double-click on B2 to select that cell address. To replace it with the range name, all we have to do is click on this down arrow and we'll see a list of range names. Right now there's only one. It replaced the cell address B2 with breakpoint. If we come over here and double-click on this cell address B2 and select breakpoint, we now have replaced both occurrences of the cell address with the cell range name. I'm going to enter that formula, and now of course I can copy using the autofill handle over and down and replace all occurrences of breakpoint. And these two formulas, again, probably want to do it separately so I don't have to redo the formulas. We now use the word breakpoint in place of a cell address. Now, when I'm trying to analyze these formulas or figure out how they work, I don't really even care where breakpoint is, as long as I know that somewhere on the spreadsheet there's a range name called breakpoint and that refers to the point at which commissions are received or not received. We can take this process of using range names several steps further. So far, we've barely tapped the capabilities of range names. We're now going to create groups of range names with one command, and then we're going to apply those range names to existing formulas without having to go in and edit them one at a time, as we did with breakpoint. Let's create some range names in the Denver spreadsheet and then apply them over here in the formulas. Let's shift-click on Denver to deselect the others. And then let's highlight the raw data, the January and February sales of each salesperson. Let's select the range on the spreadsheet where the basic data and the labels that go with it exists. That is, click and drag from cell A4 down to and including cell C9. We've got the columns with the sales in them, the headers for the columns, and the row headers as well. Let's now do an insert name create. It's going to create names based on the top row and the left column. Click OK. Now we've got names for all of these cells. Let's select somewhere else and then click on the down arrow and select, say, Brian. It goes and finds the cell's name Brian. Notice that the name cell itself, Brian, is not part of the named range. If we select February, we'll see it's all the numbers in that column under February. Next, we'd like to apply these range names to the formulas over here. Let's highlight the range where the formulas are, cell D5 down to G9, and then do an Insert, Name, Apply. It lists all the range names in the spreadsheet as being applied, except for breakpoint. Breakpoint's already been applied, so it doesn't need to reapply it. Let's click on the Options key. I think for beginners, the default method of range names is a little confusing. It has to do with these two options down here, omit column name of same column and omit row name of same row. I'm going to turn both of those options off so that when it refers to the intersection of two columns in a formula, it'll always put in both the row name and the column name. Let's click OK. Now it's applied names to these formulas. Let's select cell D5 and look at the formula. It now says equals Joel January divided by B12. Joel January refers to the intersection of the Joel row and the January column. Basically, that's the same as cell B5. If we look over here at Joel's February percent, you see it says Joel February divided by C12. Similarly, if we look at the other percentage formulas, we now see that they refer to a salesperson and to a month. Much easier to interpret than a cell address. Let's look at the bonus formulas. For Joel's January bonus, we see a formula now saying if Joel January, which means Joel's January sales, are greater than breakpoint, then the true condition is take Joel's January sales, subtract the breakpoint from that, and multiply it by 10%. If not, of course, put in the text, no bonus. These formulas are far more legible and far easier to come in and figure out what they mean at a later date. Now, if I create new formulas, let's go down to cell E13, for example, type equals, and now I can either type or paste in, let's say, Cheryl, space, and now click on the down arrow and select February, and enter. My formula is now equal Cheryl space February. That shows 15,700, which is Cheryl's February sales. I could go anywhere on the spreadsheet and refer to these range names in formulas, in tables, etc. I don't even have to know what cell addresses they occur in as long as I put in the correct range names. As you get involved with more complicated spreadsheets, you can apply range names across multiple sheets as well. In this section, we learned how to apply the logical function if to make decisions in the spreadsheet, and also how to create and apply range names in spreadsheets. As we saw in the previous section, if we want to take data from one worksheet to another in the same workbook, we can just sum across multiple worksheets. However, if we want to take data from one worksheet into another worksheet that's in a separate workbook, we have to use cell linking. Let's go look at how that's done. There's actually two possible ways to do it. First, let's create a new workbook. The way you create a new workbook is clicking on the New Workbook tool at the very left end of the standard toolbar. We've created a new blank workbook. It has 2 sheets in it because we set the default setting that new workbooks will have 2 sheets in them. And now, let's use the first method for linking data between workbooks, the formula method. Let's just take as an example, we'll go to cell B3, and we'll start creating a formula just as we normally would in Excel with an equal sign. Now if we want to go to the other workbook, we can do a window and go down here and select book 2, the one we did the previous spreadsheets in. And now we can select really any cell in this worksheet. Let's say we want to bring across the totals for Denver. Just click there. And now if I just click enter, it'll send me back to my new workbook, and we'll have copied the numbers from book 2, Denver spreadsheet, cell B12. Let's do that again. Let's label this one Denver. Let's go down here and label one for the Timbuktu office and one for Omaha. Let's come to the Timbuktu numbers, press equals, and then go back to the other worksheet, Timbuktu sheet, and click on the January totals. Press enter. Now it gets tedious working back and forth between multiple sheets. We have the two workbooks loaded. We can put them up on screen side by side by doing a window arrange command. There are different ways to arrange windows. Tiled will just put them in little squares if there's more than two of them arranged around on the screen. If there's two of them, they'll just be one on each half of the screen. If we tile them vertically, they'll be in vertical strips down the screen. Cascading means that they will appear overlapping across the screen. You may want to try all of these. We're just going to use tiled and click OK. Now we can see both workbooks at the same time. If we now want to put in the Omaha total, we can go to that cell, cell B5, press the equal sign, come over into this workbook and click on the Omaha tab. Oops, it went to Denver. Click on Omaha again and click on the total for January for Omaha. There we can see it copied the 68,000 into the new spreadsheet. We could also copy the other numbers in the same fashion, the February totals. Let's go back to book 2, click there to activate that. We're going to work in book 2 for a few seconds and create grand totals for bonuses for each office. Let's make this spreadsheet fill up the screen by clicking in the upper right corner. Now it fills our screen. It's a little easier to work on. And let's come down and select all three spreadsheets. I already got Omaha selected, so I'm going to shift click on Denver. And now I'm going to come down to cell F12 to get a total bonus. I'm going to click on the summation tool. The no bonus text in the middle of this table fools the summation tool. We have to tell it that we want to sum all cells with bonuses in them, even ones with no bonus. All we have to do though, since the F8 to F11 is highlighted, is click and drag from F5 down to and including F11 and enter it. Let's do that again. If we come over here on this cell and do a summation, this time however, since there's no bonus in the middle, it goes all the way to the top, gets the correct numbers, and enter that. We look at our other spreadsheets and we see our bonus totals in those as well. Now let's make this spreadsheet smaller again by clicking in the upper right corner on these two arrows. Not the one at the very top for the entire application, but the one below that. Puts book 2 back into its place in the arrangement. Now we can come over to our book 4 spreadsheet and link the bonus totals in the various spreadsheets in book 2. Let's go to cell B2 and type in the title, January sales, and over to C2 and type in February sales. Let's now go down to the February sales, cell C3 for Denver, and type in equals. Come back over here to the other workbook, select the Denver worksheet, and click on the February total. Enter that. down for Timbuktu February sales, put in the equal sign, click over here, click on Timbuktu, and put in the total February sales for Timbuktu. Come down here for the Omaha total February sales, put in the equal sign, come over here to the Omaha spreadsheet, click on the total sales over there, and enter that. This is the formula method of linking across workbooks. As you've seen, we have to do one cell at a time to link this way. Let's go over here now and put the total bonuses for January and February. We'll start with our headings in cell D2. This will be the total January bonus. Tab over to cell E2, and here we'll put total February bonus. You may want to widen these columns. I'll just do a best fit on both of them. Now I'm going to copy the total bonuses from the various spreadsheets over into this sheet, but I'm going to use a different method. I call it the paste link method. We start in this case from the source document or supporting document, the document the numbers come from. Let's scroll over and activate the Denver spreadsheet now, and scroll over here until we find the total January bonus and the total February bonus for the Denver office. We'll highlight those two cells. First, let's deselect the other spreadsheets. We only want to copy the totals for Denver. We'll shift-click on the Denver spreadsheet. We then highlight the cells we want to copy. Click on the copy tool. Then come over to our new book. Click here in cell D3 and do an edit, paste special. And in here, click on the paste link button. As you can see, we could copy 2 or even more fields at one click. Let's now go to the Timbuktu spreadsheet. Scroll over, highlight the cells we want to copy. This time I'll do the copy using the right mouse button. Then come over to my dependent spreadsheet, click on the appropriate cell, cell D4, and do another edit, paste special, paste link. Let's do it one more time. Let's go back over to our supporting spreadsheet and click on Omaha. Scroll over in the Omaha sheet, highlight the appropriate cells, click on the right mouse button and select Copy. Let's go over to the dependent spreadsheet, select the appropriate cell or cells, click on the right mouse button and select Paste Special. This time, let's just mention some of the other options we have in the Paste Special dialog box. The default is to paste all, that is, formats, formulas, whatever is in that cell into the new cell. We can also just paste the formula, that is, without any formatting or any notes. We can paste the value. This is how you copy a number that is a result of a formula from one cell into another without copying the formula. We can copy formats, although Format Painter does this much more easily. And we can also copy cell notes. We can attach a note to each cell in the spreadsheet and then copy those to other cells using Paste Special. Further, in this center box in Paste Special, we can take cells that have values in them, copy them, and then paste them on cells that also have values in them, and using Paste Special, tell it whether we want to add, subtract, multiply, or divide the contents of the two cells. Let's just go ahead and click here on Paste Link. We now see our complete numbers over here in the dependent spreadsheet. Let's blow up this spreadsheet, and now we can see our new spreadsheet with our total January and February sales for all three offices and our total January and February bonuses for all three offices. Notice the formulas where we use the edit paste link command. The formulas are enclosed in curly brackets. This is a special kind of formula called an array formula. Well, notice that if we go in here and try and edit, for instance, a cell address and enter it, we get a dialog box telling us that we cannot change part of an array. In fact, the only thing we can do is escape out and put that formula back the way it was. Array formulas follow a special set of rules. They're beyond the scope of this class, but suffice to say here that they're very handy for copying large numbers of fields, but we can't go in and edit them as we can normal formulas. Note that when we open a spreadsheet that's dependent on another spreadsheet, it'll ask us if we want to update references to that other spreadsheet. We can tell it yes or no depending on what we want to happen. You've now seen the two different methods of linking spreadsheets, the formula method and the edit paste link method. Each method has its advantages and disadvantages, and you have to choose which one you're going to use based on your knowledge of how the spreadsheet's going to work. In this next section, we'll delve into the next most used group of Excel paste functions, the financial functions. In fact, we'll create a very useful table, an amortization table. This is used, of course, to calculate what portion of a loan is interest and what portion is principal on a monthly basis throughout the life of the loan. This is very commonly used by accountants, banks, and so on and so forth. And it's a nice thing to have for ourselves in our own spreadsheet. When we consider borrowing money anywhere, we can plug the numbers into the amortization table and look at the overall picture of how the loan shapes up. Let's close Book 4. We'll double click up here in the left corner. Tell it yes, we want to save changes in case we might like it later. And I'm content with the name Book 4, so I'll just click on OK. I won't put any summary info in for this table. Let's also close Book 2. Now let's open up a new workbook, Book 5. Let's make it fill the screen. And let's create our amortization table. Let's go down to cell A6. In this cell, we'll type in duration. Tab over to cell B6, and we'll start out with a duration on the loan of 2 years. Tab on over to cell C6, and in here we'll type in interest rate. Tab to cell D6, and in here we'll put 12%. That's an annual interest rate. Let's tab on over now to cell E6, and in here we'll put in the amount of the loan. Enter that. Finally, go over to cell F6, and let's say the amount of the loan is going to be for $10,000. Now let's come down below, and in cell C8 we'll put in here payment. We now have the basic data that Excel needs to calculate a monthly payment. We'll now insert the payment function. We'll go up here and click on the function wizard. This is a financial function, so we'll select financial. In here we find a function called PMT. That's the payment function. Click on next. The 5 arguments for the payment function are rate, that's interest rate, N per, that's the total number of periods in the loan, PV, which stands for present value, that just means how much money did you borrow or loan to someone, FV is future value. You'll notice that these last 2 arguments are in lighter text. That tells us that these are optional arguments and we don't have to fill them in if we don't want to. Future value would be if there was a balloon payment on the loan. We won't have one on our loan. And type is variations on how the interest is calculated. We'll just leave those two at the default settings. Let's go back up here to rate. Interest rate we already have on our spreadsheet. Let's move the wizard box out of our way a little bit and click on the cell that we put the interest rate in, cell D6. Now you notice that this is expressed as a decimal fraction equivalent of the 12% we put in there. However, it's important to know that the interest rate is expressed in terms of an annual rate in our table, but in terms of a monthly rate in the formula. We enter our interest rate in the table as an annual percentage. That's how I usually think of interest, and that's usually how it's advertised and how the bank gives it to us. However, Excel wants the interest rate based on a per payment basis. In other words, per month in this case, since this is a monthly payment loan. We have to adjust the annual interest rate to a per month interest rate. We simply do that by dividing it by 12. We put in our slash for division and the 12. Then let's tab down to the end per, the number of periods. Well, that's in cell B6, sort of, because we're saying 2 years here for the loan, but as far as the software is concerned, really this is a 24-month loan. That is, there are 24 payment periods. So if we want to express the duration in the table in years, we have to adjust down here by multiplying by 12. That'll give us 24 periods, as you can see here. Finally, in the present value field, we just want to select the loan amount, cell F6. That's inserted into the PV field. That's the 10,000, and that doesn't need any adjustments at all. We can just click on Finish. That now inserts the formula equals PMT paren D6 divided by 12, comma, B6 times 12, comma, F6. I didn't pay any attention to cell addresses in this formula because we're not copying this formula anywhere else. There's only one monthly payment for the entire duration of the loan. Next, we're going to add columns down below for the additional information we need to create a table showing us what portion of that monthly payment is interest and what portion is principal. Of course, that varies month to month, and that's the whole purpose of an amortization table. We'll start in cell A10 and put in our title for the first column, which will be payment number. Then let's tab over to the next column, and here we'll put in the date. In the next column, we'll put in the interest portion of the payment. In the fourth column, column D, we'll put in the principal portion of the payment. And in the last column, column E, we'll put up the loan balance. Now, these columns are too narrow to display the full text. We could widen the columns, but that would make them very wide, much wider than the numbers that are going to appear down below. So let's highlight this title row and do a Format Cell and select Alignment. And down here, this little box right here, Wrap Text, OK. It adjusted the row height of that row, and now we can fit the full title of each column into a single row. Let's start now in cell A11. This is payment number 1, so we'll just enter the 1, and down below we'll put in a 2. To continue this series down for 24 months, all we have to do is highlight both cells. We can then grab the autofill handle, and since we have 2 numbers selected, it will repeat this series. We want to go down for 24 months. We can stop anywhere along the way to see how close we are. We're only to 15, so we want to go a little further. Oh, I got lucky. Got 24 on the first try. If I'd gone too far, of course, I could just clear out the cells underneath. Let's go back up now to the top of our sheet, and in here, let's put in January 1994 as the starting date of the loan. We have to enter this date in an acceptable Excel date format. One of those would be Jan-94. If we do it in an acceptable format and enter it, Excel will recognize it as a date and we won't have to format the cell. We could click and drag on the autofill handle and go down for 24 months, or we can use this handy new feature of Excel 5.0. Put our cursor on the black cross and double click. It automatically autofills down even with the data in the column to the left. Now we want to enter our interest payment formula. This is another paste function. We'll go up and click on the function tool. It's a financial function. Of course, you'd have to know from having looked it up in the manual or something that this formula is the IPMT formula, interest payment. Select that formula and click Next. This formula wants very similar arguments to the payment formula. The interest rate, here's a new one, per. That's the period number. The payment didn't depend on what period it was of the loan, it was always the same. However, the interest and principal both will vary as each payment of the loan progresses. N per is still the total number of periods in the loan, and PV is still the loan value. Let's start by entering the rate. The interest rate is already here at the top of our table. That's in cell D6. However, when we enter this cell address, we want to consider whether this should be a relative, absolute, or mixed cell address. Well, where are we going with this formula? We're going to be copying it down this column. If we leave this relative, it's going to look in the cell below to cell D7 for the interest rate. Cell D7 is blank. That would give us a very nice interest rate, 0%. Unfortunately, I don't think I can find a bank that'll do that. So I want to make this an absolute cell address by pressing F4. That way, when we copy this formula downward, it will always go back to cell D6 for the rate. We also have to adjust this rate. Remember, this is an annual rate, and in our formula we want a monthly rate, so we're going to have to divide it by 12. Let's tab down to the per column. That's the period number or the payment number. Let's just click over here, cell A11. Now, what kind of address do we want here? Well, as we copy this cell down, we would like the address to move down with it. So the relative address works just fine here. Let's go down to the number of periods, the next field. That's up here under duration. Let's click on cell B2. Sorry. Let's click on cell B6. And now let's think about the cell address. We want to always come back to this same cell for the duration, so we're going to make that an absolute address. We also had to adjust this one to become months. Right now it's expressed in years, so we're going to multiply this one by 12, just as we did in the payment formula. Pull the box up a little bit, and now we come down to present value, the next item. That, of course, is up here in cell F6. Click on cell F6, bring the box back up, and now let's think about the cell address. We always want to come back to cell F6 for this information, so we'll make that an absolute address by pressing F4. Let's click on Finish. It now tells us that our interest payment is going to be $100. Notice, by the way, that both the interest payment and the monthly payment are in negative numbers, in red in this case, and in parentheses. That's because our loan amount was a positive number, $10,000. We could complete the principal payment field by clicking on the paste function box and going through a very similar procedure to what we just did for the interest payment. However, I know from previous experience that the arguments for the principal payment are the exact same arguments as the interest payment, And I also know that the only difference between the two is that interest payment is IPMT and that principal payment will be PPMT. So I'm going to use a shortcut to put the principal payment formula in here. I'm just going to autofill from I payment over into principal payment. We get an error message at first, but we're going to fix that. I click on this cell, and I'm going to make two changes. I'm going to come up here and change this I on the entry line into a P. That changes the function to P payment. The other error is that it's referring to cell B11 looking for the payment number. I just want to change this B to an A and now enter that formula. There you can see my principal payment, and I'm pretty sure all this is correct because the principal payment and the interest payment added together equal the total payment. I used a shortcut to get the principal payment in here without having to enter each of the arguments in turn. I just copied the I payment function over, changed the I to a P, and corrected one cell address. Now let's calculate the loan balance at the end of the first month. The loan balance is going to be the loan amount minus the principal payment. Interest doesn't count toward principal, toward balance. However, the principal payment is already a negative number. So in the actual formula, we are going to add the positive number here to the negative number here, which is going to give us the correct amount here. Let's put on our equal sign. Come up here and click on cell F6. If we think about what kind of cell address we might want here, it really doesn't matter because the balance formula for the rest of the months is going to be different than this one. So I'm just going to go ahead and put in the add sign and then come over here and click on the principal payment. Remember, the principal payment is a negative number, so I'm really subtracting D11 from F6. If we enter this, the result is $9,629. The balance should be going down, so that's correct. In the next month, the balance we're going to calculate slightly differently. Let's autofill these two formulas down one cell so we have our next month's interest and principal payment. To calculate the balance for the second month will basically just be the previous month's balance minus the principal payment for this month. Again, the principal payment is already negative, so in our formula we're going to add these two numbers together. Hit equals. I'm going to come up here and click on the previous month's balance. Now this formula, I am going to copy down the rest of this column. So what kind of cell address do I want here? Well, I always want this formula to go to the cell directly above it, the previous month's balance, and then I want it to subtract the principal payment, really add it, because it's a negative number. So relative addresses work just fine here. Now I can take all three of these formulas, come up here and double click on the autofill handle. Coming down to the bottom of the spreadsheet, we see that the loan balance has zeroed out in the last month. Amortization tables are friendly in that they are self-checking. The loan balance on the last month should always be zero unless there's a balloon payment, in which case that last month should show a balloon payment of that amount. We've now created an amortization table that's very flexible. We can change the loan amount, for example. Let's put in $5,000. Enter it. You'll notice that immediately the table changes to reflect this new loan amount. We could change the interest in a similar way. We are a little bit restricted by the duration. Our table is only 24 months long. However, if we wanted to enter durations longer than 2 years, all we'd have to do is come down to the bottom of the table and extend the table downward for however many months we wanted it to be. Let's show you another feature of Excel You'll notice as we scroll down in a large spreadsheet like this, we get down below, there are no labels on the columns. If we want to know what's in each column, we have to scroll back up. There is a method called freezing panes that allows us to hold these panes at the top of the spreadsheet. Let's first just scroll down. Let's say we still want to see our input numbers up here as well. So let's just come down and click here on cell A11. We want to freeze everything above that in the screen, and then when we scroll down, only this portion of the spreadsheet will move. The input amounts, the payment, and the labels for the columns will stay fixed on screen. Let's now do a window freeze panes command. Notice the heavy line above the cell we selected. Now if we scroll downward, you'll see that the labels stay on screen, and we can scroll all the way down in a spreadsheet and see the numbers and see the appropriate labels that go with each column. The same thing would apply had we clicked on a cell and left columns outside. It would have locked however many columns we showed to the left of the selected cell when we froze panes. So you can have the first column or several columns frozen, and then you can scroll sideways in the spreadsheet and always see the labels in those columns. For example, if we come over here now to the second cell and do a window unfreeze and then a window freeze panes, we now have frozen both vertically as we were before and also horizontally. Our first column with payment numbers always stays on screen no matter how wide the spreadsheet might be. We can unfreeze the panes to put the spreadsheet back to the way it normally operates. We can also use another feature of the software to do a similar thing, but this feature will enable us to scroll in either portion of the screen. Let's click here on cell A16. And now let's do a window split. This now splits the screen into an upper and a lower half. And we can see the whole spreadsheet or any portion of it in either screen. So I can scroll down in the bottom half, still see these numbers in the top half, and I can also scroll down in the top half. If I scroll back up in the bottom half, I'll actually see my labels down below. This also works in both a horizontal and a vertical direction. Let's remove the split. We simply do a window remove split command. And we're back into a single view of the spreadsheet. Let's also talk here about how to get rid of an unnecessary sheet in a workbook. We'll keep sheet 1, our amortization table, but we have an extraneous blank sheet, sheet 2. We'll delete this sheet. If this sheet had data in it, we delete it just the same way. We do an edit, delete sheet command. We always get a warning when we do this. Of course, we can lose a lot of valuable data. We click OK, and now sheet 2 is gone. This book now contains only one sheet, our amortization table. We've now worked with 3 financial pace functions: the payment function, the interest payment function, and the principal payment function. We kind of cheated a little using the principal payment function. I'm very proud of that. When you're working with spreadsheets, it helps to be lazy. It's much quicker, and usually you create more powerful, more flexible spreadsheets by reusing data that you've already created somewhere else. We also learned how to freeze panes and how to split panes for manipulating the screen so we can see what we need to see as we move around, particularly in large spreadsheets. Now we come to the fun part, creating charts. Working with all these numbers can get awfully dry and awfully boring. Most of us like to see these numbers represented as charts, particularly colorful charts, and Excel has a plethora of these. Let's close our amortization table. We're done with that. Now let's reopen Book 2. These are the spreadsheets we created for the imaginary sales offices of our company. Let's go select the Timbuktu sheet, one of the trickiest parts of creating the graph is deciding what data to make the graph of. That just comes from experience. I don't know of any simple rules to give you. We're going to graph the names of the salespeople, the months, and the raw data that was used then to calculate the rest of the spreadsheet. So we're going to select from cell A4 down to and including cell C8. Now we're going to go up to the toolbar and select this tool with the little graph and the little magic wand over it. This is the chart wizard, and this walks us step by step through the process of creating a chart. When we click on it and move the cursor down into the spreadsheet, it turns into a cross with a little chart next to it. Notice down on the status line it says drag in document to create a chart. I'm going to click and drag underneath my spreadsheet. I'm going to create a box about a full screen full. If the chart's too small, it's very hard to see and manipulate. It really doesn't matter how big you make it. It's very easy to correct once we're done creating it. The software is now asking us, is this really what we want to graph? Cell A4 through C8? It is. So I'm going to click on the Next button. Now it comes in and gives me a selection of all the various types of charts that Excel can do. We'll leave the default the column chart, but once we've created it, we'll look at a few of these other types of charts. Let's just click on Next. Now we see the 10 different formats for column charts. There are quite a few of them here. Each of the other charts has several formats as well. Let's select number 2 and let's click Next. Now we see a sample of what our chart's going to look like as it stands right now. You'll notice the dollar amounts over here on the left and the salespeople down below. The 2 bars represent the 2 months, January and February. The first choice here is Data Series In. I think of a data series as what would be a line on a graph. In this case, each line would represent a month. There'd be a line for January and a line for February if this were a line chart. If we click on rows, right now the data, that is, the line is in January and February, is in columns. If we click up here on rows, now you see it changes the chart. Now we see January down here and February, and we see each salesperson compared within the month. Either format would work for this chart. I think I'll leave it with this one. We have another option here asking if we want to use the first row of the spreadsheet for the x-axis labels. The x-axis is the axis across the bottom here. So it's using the top row of the spreadsheet, the row that has January and February in it, to label this. That's just what we want it to do. It's also asking us, do we want to use the first column of the spreadsheet for the legend text? That's the text in here. Those are the people's names, and that's also just what we want it to do. We could select a different row or a different column for either of these. Also notice that we have a back command. If we decide that a decision we made somewhere earlier in the chart wizard was wrong, we can click on the back button and go back to the previous screen. I'll just click Next and leave my choice there, and click Next again to go on to the next screen. This screen asks us, do we want to add a legend? Well, the legend's already shown here. We could take it off if we wanted to, but I think I'll leave it there. We can also come over here and put a title on the chart. Let's put in here Sales. We can also put an axis title for the x-axis. We already have January and February down here. We could add a year or something like that. Let's do that. Let's put in 1994. And on our y-axis, these numbers represent dollars. So let's label that. It now changes the chart to reflect the text that we put in around it. The title at the top, the dollars label over here on the y-axis, and the year down here under the months. If we click on the Finish button, we now see our chart embedded in the spreadsheet. We can scroll down and see the entire chart. If we want to do further work on this chart to customize it, all we have to do is double-click on it. The first time you do this, the charting toolbar will appear. Since mine didn't appear, I'll come up here and put my cursor on the toolbars and click with the right mouse button. Then I'll select with the left mouse button the charting toolbar. The charting toolbar gives us shortcuts for working with the chart. Over here at the left end of the charting toolbar, we can select a chart type. Click on the down arrow, we will see a list of the basic chart types in Excel. Area charts, 3D area charts. Let's select an area chart. Doesn't mean much for this particular type of data. A 3D area chart is even weirder for this data. We'll look at 3D charts later on. We can also make it into a horizontal bar chart, a line chart, and various others. Pie charts, XY scatter charts for scientific use, donut charts, radar charts, and so forth. Let's go back because really for this particular data, the column chart gave us the best representation. We already have a legend, so we don't have to use this button on the tool, the legend tool. This tool allows us to insert and change horizontal grid lines in the chart. Let's click on that, and now you see it just put grid lines in for us. If we want to get rid of them, we just click on the grid lines tool again. We can modify just about anything having to do with this chart. The chart is made up of what we call objects. The Y scale is an object. If we come over and click on an object, we'll see boxes at either end telling us that that particular scale is the chosen object. You'll also notice up here on the entry line it says axis 1. If we click down here on the horizontal scale, we'll see up here it says axis 2. And so on throughout the chart. Let's change the formatting of the vertical axis first. Come over here and put your arrow on the vertical axis and double click. This brings up the Format Axis dialog box. The first one, the selected one, is alignment. I don't really want to change the text alignment here. We can change the formatting of the numbers, but I'm fine with those. The fonts, we'll leave those as they are. Let's click here on Scale. That's one we may want to change. If you look in here, you'll see that it's all been done automatically. The various values that we can set for the scale when we originally set up the chart are set to automatic settings. We can change any or all of these. For instance, if we change minimum here, which right now is at 12,500, where our chart starts, we can change the whole perspective of the chart. Let's do that. Let's change the minimum to 0. We'll leave the maximum for now at 16,000, but we could change the maximum value and actually either extend the chart upward with just blank gray area or cut off the chart at some point before we get to the highest bar. On the major units, those are the numbers that we see over here. Those are 500 apart, but if we're going to expand this chart to go from 0 to 16,000, we may want to change the major units to 1,000. And now we'll make the minor units 500. Minor units will appear as little tick marks on the inside when we get to patterns. Category crosses at 12,500 at the 0 value. We want to change that to cross at 0 also at the bottom of the chart. We can also make a logarithmic scale. We can reverse the values, turn the whole chart upside down. And we can also make the axis cross at the top of the scale instead of at the bottom. Let's go over to patterns now. What we see in here are the patterns that we could choose for this axis. The line that composes the axis is normally just a thin solid line in black. We could change it to a dashed line or a dotted line or even to a form of shading. I've done it. It doesn't look very good. We could change the color if we wanted to, and we could change the relative weight. We'll leave these the same here though. We can also change the relative position of the tick mark labels with respect to the axis itself. For this vertical axis though, next to axis works best. We can change the tick mark type. On the major axis right now they are outside and there are none for the minor axis. We'll leave the major axis outside, but we'll click on inside for the minor axis. Let's click OK now and see what our new scale looks like. You'll notice why originally Microsoft Excel cut this chart off at about 12,500. The differences between the different people's sales for the month of January are relatively small compared to the overall numbers. However, this does more reflect reality. That is, that the relative sales of the different salespeople are pretty close. We have a rather crowded vertical scale here. We might want to go back in and change this to like 2,000 or even 4,000 for the major axis and 1,000 or 2,000 for the minor. Let's look at the horizontal scale now, the one with January and February on it. Let's just point to it and double click. We see basically similar choices in here. We can set the axis type, we can change the location of the tick mark labels, and we can also change the tick mark type. On this axis, actually, tick marks don't add anything to it, so I'll just make none for both. On the scale itself, we have some different choices here. We have a value y-axis crosses at category number. In other words, where does this vertical axis with numbers cross the horizontal axis? Usually we want this at category 1, which is where it is right now. However, we can move it over so it crosses down through the middle or the far end of the chart. We can also tell it how many categories we might want between the labels. Normally we leave that at 1, but sometimes when the labels overlap, we might want to make it every 2 labels. For example, if we had a chart where the labels at the bottom were similar to this one, January, February, but it was a much tighter chart, and the February and the January ran together. Well, most everybody knows what the months of the year are, so we might have it put in a label every 2 months instead of every month. Then we would see down at the bottom January, March, May, and so on, and people would just have to assume that the columns in between represented the months that weren't shown. Finally, we can change the number of categories between tick marks, which the default is 1. We've taken out all tick marks, so that one really doesn't apply here. We can also change some of the relationships. We can say the y-axis crosses between categories. Categories in reverse order. We can turn that bottom axis around the other way. We could also make the y-axis cross at the category with the largest value in it. Fonts work the same, number the same, and alignment of what we've seen before, so we'll skip those and just click OK. All we really did here was remove those little tick marks. Next, we might want to put a text box, some kind of comment on our chart. The text box tool is up here on the standard toolbar. Click on that tool and then come down into your chart and click and drag to create a text box. Once you create it, you can just start typing. You can do a number of different things to this text box. Get the arrow up next to it and click on it. You can select it. Once it's selected, you can either put the arrow up here on the border of it and click and drag it and move it anywhere you want on the chart. You can also resize it by putting the cursor on any of these little boxes around the edges and clicking and dragging on those. If we double click on the text box, we bring up the Format Object dialog box. This is very similar to the dialog box we saw for the axis. We have a choice of the border patterns around the edge of the box. These are the same choices we had for the line on the axis, and in fact for any line that we create in Excel. We can also put a drop shadow behind the box, and if we like, we can round off the corners. Notice as we make selections, over here in the lower right corner we see a sample box showing us what our text box is going to look like using the current settings. We can also put in fill, some sort of color, and if we want, some sort of pattern. There's quite a few rather wild patterns here. However, most of these would badly obscure the text in the box, so I don't think we really want to use those. Of course, the font box allows us to change the font in our text box. We can select a style, and we can select a font size. We can also underline it with different types of underlines, change the color of the text, and make the background either transparent, opaque, or an automatic selection. Let's make this opaque. We can also have a strike through and also make it into superscript or subscript if we like. In the alignment box, we can change the location of the text within the box. I'm going to center it both horizontally and vertically. And we could, if we wanted to, change the alignment of the text, that is, stack it or have it running upward or downward. In protection, we can lock or unlock it. And finally, under properties, we can make it separate from sizing of the chart or sized with the chart. Let's click OK. And now we've created our text box. I made it a little too small to show all the text, so I'm going to make it a little bigger now. Click somewhere else to deselect it, and now you can see what that might look like. Next, let's put an arrow on our chart. To do that, we're going to go to the Drawing toolbar. To get a list of the toolbars up, all we have to do is put our cursor up here on the toolbars and click with the right mouse button. This gives us a list of toolbars. There are more under the Toolbars command, but the Drawing toolbar is here, so we'll just click on that, and now it appears. One of the many tools on the Drawing toolbar is the arrow tool. Click on that tool, and then come down here in your spreadsheet and click and drag from wherever you want the arrow to start to wherever you want the arrow to go in the chart. If you want to change this arrow, put your cursor on it and double click. Get another Format Object dialog box. Properties, Patterns. Notice in Patterns, when you choose an arrow, we have the same choices for a line, but we have a number of different choices for the arrowhead. It can be filled, or hollow, or an arrow at both ends. We can change the width of the arrow point, and we can also change the relative length. Down here is our sample to show us what our arrow is going to look like. I'm going to click OK, and I've just changed the shape of the arrowhead a little bit. Remember that this graphic object, this arrow, can be moved anywhere you want simply by clicking in the center of it and dragging it somewhere, or by clicking at either end and dragging the ends to where you'd like them to be. We've done some basic formatting to this chart. Now let's look at working with data series. That is the equivalent of what would be a line on a line chart. Each of the colors on the chart represent a data series. That is, each person is a data series. To change the colors on the chart, all we have to do is go to the series we'd like to change the color of. Let's say Harry, the medium blue, and double click. Again, we see a Format Data Series dialog box. The patterns we can choose for the border, again, are the same as for all lines. For the area fill, we can choose all these various colors, and again, all the same patterns. We can also change the axis. We'll leave that as it is. We can change the X values. Right now the X values are in cells B4 to C cell in the spreadsheet, so we don't want to change that. Let's click up here on Name and Values. The name field shows us Timbuktu cell A5. That's the series name of the series Harry. And the Y values are in cells B5 through C5. We can edit any of these. Error bars are for more sophisticated kinds of charts. Data labels enable us to put additional labels on the sheet, such as show value. Okay, let's click OK. And now we'll see that the actual sales amount for Harry in each month appears above his bar. We could put data labels on the others as well. It probably never happens where you work, but where I've worked many times after I've completed a chart of this type, someone comes along and wants to add more data to an already existing chart. Well, with Excel 5.0, we're one up on them. Let's scroll up to the spreadsheet and let's add a new salesman, Henry, and put in the sales data for Henry for January and February. Enter that. Now, to bring this new data series into the chart, all we have to do is highlight the data we want to add, and we'll copy it. We'll hold down the Control key and click and drag and pull it down into the chart and let go. Let's scroll down and look at the chart again. And now you see there's a new data series, this dark purple one, for Henry. We can just drag and drop the new data series into the chart. Now let's take a look at 3D charting. Let's take a look at 3D charting and some of the options in Excel to manipulate 3D charts. We'll use this same chart. Let's go up to the chart toolbar, click on the down arrow, and we'll select this little chart right here. This is a multiple column, multiple row 3D chart. We let go of it, our existing chart just changes into this new format. Our axis here is rather crowded. We might want to make some changes there. Just double click on that axis and come in here and change the scale. Let's go back to automatic settings. And click OK. Now I see we're back to nearly the original scale we had when we started, and we have a little more variation between the various boxes. Now we have the chart selected. Let's come up here and do a Format 3D View command. This is the 3D View dialog box. From here we can manipulate the chart in a number of different ways. Let's start over here on the left. We can change the elevation, that is our view horizontally or vertically of the chart. If we click on this arrow, our elevation increases 5 degrees at a time. Notice the little cage, as it's called here, moves as we click to give us an idea of what's going to happen. If we want to see it on our actual chart without closing the 3D view box, we can move the box out of the way a little bit and then click on Apply. We now see our chart from an entirely different view. Also notice it got considerably smaller. We can also type in an elevation. We can also change the angle of rotation. We can rotate our chart in either direction. And again, if we want to see what it looks like, we just click on Apply and see what it would look like on the actual chart itself. We can also change the perspective. Let's click on this little arrow pointing upward. This will minimize the perspective. We click on the other one. This exaggerates the perspective. This is certainly a very easy way to distort data to make things look different than what the numbers would really indicate. We can also make the axes run strictly at right angles. We click on right angle axes now, click on apply. Gives us a very strange looking chart. I'm going to turn that back off. We can also change the ratio of the height to the base. Let's make it 200% instead of 100 and click on apply. This makes the bars much taller. If we change this to 50% and click apply, now it makes the bars very short. You can also click on the default button that sets all of the various settings in the 3D view back to what they originally were when we came in. Let's go to our chart itself now and click on one of the corners around the edges of the chart. Now if we click and drag on one of these corners, we can actually manually rotate this chart in 3 dimensions. It's pretty messy at times. Notice that it also makes very dramatic changes in size depending on the angle we look at it from. Finally, we'll create a donut chart, which is an ideal chart to show the percentages of each salesperson for the 2-month period. This also shows us how to select data that's not in adjacent cells to create a chart. First, let's scroll back up to our spreadsheet and select the data that we want to chart. I'm going to chart the first column, which has the names of the salespeople. We also want to chart, holding down the Control key, the January and February percent columns. To create a chart, you just come up here and select the chart type. We'll use the donut chart. Don't worry, it's not fattening. And now let's click and drag and make a chart box about the size of a full screen. Resize it, we just grab the corner and drag down. Like other charts, we can change different aspects of this chart. If we double click on one of these areas on the chart, we bring up the Format Data Labels. We can change the border around the edge of this, the area fill, the font within it, any numbers that are inside it, and the alignment of the labels. If we put our cursor right on the edge, the outer edge of either one of these series and double click, it brings up the Format Data Series dialog box. Again, we can change the patterns of the area. We can change the axes. Doesn't make much sense to do that with this chart. We can change the name and the values, the field where the name of the chart came from, the name of each field came from, and where the values for each field came from. And we can also change the data labels. Right now, it's just showing the label, that is the name of the series, the person's name. We could also have it show a percentage, the value that goes into that field, no label at all, or a combination of label and percent. Let's select label and percent and click OK. Now in our outer ring, we have a label and a percentage. On our inner ring, we have a label, which doesn't make much sense. Let's go to the dividing line between 2 series and double click there. This brings back up our data labels. This brings back up our data labels box. And now in this one, we can just show percent, since the other ring already has the labels inside it. Now we have on the outer ring the value, and the label, and on the inner ring just a percentage value. Donut charts can show us multiple percentages for the same category, kind of like overlapping pie charts. In this section, we've seen how to create charts using the chart wizard and many of the charting features of Excel 5.0. In this course, we've talked about order of operations, paste functions, 3D spreadsheets, linking, and charting. In our next course, the Advanced Excel 5.0 course, we'll discuss databases, pivot tables, and macros. These are very powerful functions of Excel 5.0. It's been fun working with you on this course, and I look forward to working with you in the advanced class.